Good afternoon.
Good afternoon.
So how's everyone today?
Doing pretty good. How are you?
I'm all right, thank you. Thank you. Let's see. Do you have everyone there in Mogian?
Rachel was just here, but I don't know where she
That's
is.
probably her knocking on the door.
Okay. All right, and let's see. I think we see everyone there in St. John's. Your camera's angled a little high. There, perfect. Okay, that's good. All right. All right, well, let's
Yeah,
go.
Rachel's here right now.
All right, wonderful, Rachel. Now we can start. Okay. Let's go through the schedule here for the next couple weeks here. Or anyway. Okay, so today we are going to finish chapter 4. So 4.7. All right, then tomorrow and Thursday we will not have broadcasts. We are just going to be taking quizzes. Let's see. Okay, so so what I'm wondering is that if so tomorrow where you'll have your regular testing time plus class time, is it too much to do 4 quizzes? Because what I'm wondering is that if we can get the test in Thursday, then we'll be pretty free and clear for next week. I mean, then, so here's what a little bit of my dilemma is it seems like it's pushing it a little bit. And so, but next week, I don't want to have class on Wednesday, and I would just like to have it be, because we're going to have a regular class Monday and Tuesday of next week. But then Wednesday, I would kind of like it so that we just did like a quiz or something sometime during the weekend and not meet on Wednesday. But is that too much to do 4 quizzes in one day and then the test the next day? How are you guys as far as caught up and studying?
As long as we're not doing all kinds of work.
Say that again?
We're good.
Okay. Anyone concerned about it? I mean, because if you're behind in studying or whatever for the quizzes, it would be a lot. But if you're kind of caught up and you just need to review 4.7, anyway, 4.6 is pretty easy. But I don't want to overwhelm you here. So any concerns, please tell me right now, and we'll try to come up with another plan. Okay, so what I'm thinking is that, okay, so normally you have a time to do your quizzes, and what I'm gonna do is I'll open up the 4.4 through 4.7, and I'll open it up basically. Let's see. Oh. So Mogion, you guys take yours at 10:15. What I'm thinking about doing is opening up all 4 of them for not only the hour of class, but then the regular hour that you take quizzes, so that you'll have all 4 quizzes open for 2 hours. Does that make sense? So then if you're ahead, you can knock them out, or if you need more time or whatever. Okay? And so Mogion's at 10:15 is their other quiz time, and then Winslow, are we doing yours before or after class or what? So you'll have the hour of class plus what other hour do you want? And St. John's, how about you? You guys? You
So
want the hour before?
I think the hour before would work good.
Yeah.
No. Wait, we're not broadcasting, right?
Right, we're not broadcasting. So you'll have the whole hour of class plus I want to give you another hour, either before or after class.
Okay, yeah, so the hour before works great.
Okay, so before.
And we can also do the hour before.
Okay. And then Mo-Yan, we'll do you at 10:15 to 11:15. Would that work out best for everyone? And then the hour of class. Yes? Okay. All right. So then Thursday, then you'll have the chapter 4 test during class time. All right. Then next week we will have we'll have regular class on Monday and Tuesday, and then Wednesday we're not going to have the broadcast. So if I give you a quiz, it'll be like a take home, like it's something that you could do at home. And there I'm going to have it open for the whole weekend, like 3 or 4 days. Okay. So if I do a quiz at all, it's going to be extremely flexible for next week. And so, because MPC is open and I'm supposed to have class on Wednesday, but I'm not going to. We'll just do it this way. And so that way no one has to come in on Wednesday. All right. So we all good on that? Okay. All right. So let's go ahead and get started on 4.7. Okay. Again, this is the last section in chapter 4. And I think you'll find that there's really, well, anyway, we'll just start doing it. Okay. All right. Okay, so this section is on antiderivatives. So we've been doing derivatives, and so now we're going to talk about what an antiderivative is. And this is going to kind of set us up for really the next month. Is what we're going to, or, till the end of class, till the end of this course, this is going to be our next big focus. Okay? All right. So first of all, finding antiderivatives. Many problems require that we recover a function, capital F, from its derivative f. If such a function exists, it is called the antiderivative. Okay? So the idea is that up to this point, we've been given a function and taken its derivative. Now we're going to go back the other way and say, okay, given a function, what function would have that for the derivative? And so we've done that a little bit already in dealing with velocities and accelerations and things like that. Only now we're going to try to make it a little more structured. Okay, so a function f is an antiderivative of f on an interval I if capital F prime gives you the function. Okay, so we use capital F as the notation for the antiderivative of the lowercase function f. Okay, and then we'll introduce another notation here at the end. Okay, so it says find the antiderivative for each of the following functions. So the first one, f of x equals 5. So what function would have 5 as its derivative?
5x.
5x. Now, because it could be 5x plus 2 and 5x plus 3 and just 5x or 5x plus 7, what we're going to do is put 5x plus c, where c could be any constant. And then I want you, on your paper, I want you to make sure that don't just put 5x plus c, but put capital F of x equals 5x plus c. Okay, so next, what would be the antiderivative of sine x? Or in other words, what function has for its derivative sine x?
Negative cosine x.
Negative cosine x. So then I want you to write capital G of x equals negative cosine x plus c. All right, so now everybody kind of do this one, write down c on your paper. Make sure that you get the notation right. All right, so Chloe, what do you have for C?
Capital H of x equals 5x minus cosine x plus c.
Beautiful. Okay. Any questions on that? Okay. So when we have the plus c at the end, that's what's called a general antiderivative. So the general antiderivative is capital F of x plus c. All right, now this isn't on your paper. This is just kind of an extra slide I just threw in there. That there is, finding a derivative, finding a function from a derivative, there's actually an entire class on that called differential equations. And so what happens is a lot of students, depending on what their major is, after Calc 2, they might not need Calc 3. Instead, they'll go to differential equations. And so just kind of just know that that's what that class is all about. It's given a derivative, coming up with the function. And so it has a lot of the same material in it. Okay. All right. So this says finding a curve from its slope. So to do this, we have a function and a point. And so it says find the equation of the curve whose slope or derivative at a point is 3x squared. And the curve passes through this point 1, -1. All right. So so this is like the slope of the point, that's like the derivative. So then the first question, the first thing you think of is what's the antiderivative? What function has 3x squared as its derivative? So what would that be? What function has 3x squared as its derivative?
X cubed plus c.
X cubed plus c. So you say y equals x cubed plus c. So that's the general solution when we have the plus c. Now, when we're given a point or an initial condition, as it's called, that helps us figure out what the c is. So you plug in 1 for x and -1 for y and figure out what c is. So 1 for x, -1 for y, and when you solve it, you get c equals -2. Then you take that -2 and plug it back in for c in the general solution, and you get what's called the particular solution. So there's no c in the particular solution because you've solved for it and plugged it in. All right, so in practice 2, it says find the antiderivative that satisfies that initial condition. So you're going to use the capital F of 0 equals 4 to figure out what c is. Okay, so see if you can do that. All right, so David, when you've got it, let us know.
Wait, did you say David?
Yes.
Sine x plus 4.
All right. So, and remember, capital F of x equals sine x plus 4. All right, beautiful. Good job. Any questions on that? Now, hopefully you're finding this easy, and as we go through some of the rules, because you're going to have a lot of questions on this, okay? This will be tested very heavily. I'll just tell you that right now, okay? All right, so next, to give you some formulas. All right, so when we're taking derivatives, we have what we call the power rule. Okay, this is what I call the anti-power rule. So this says if you have the function x to the n, to do the antiderivative, you raise the power by 1, so you add 1 to the power and then divide by that new power, plus c. All right? The next one, if you have the sine of k times x, so like the sine of 3x, then it's the negative cosine of kx divided by k plus c. So this is sort of like the anti-chain rule. Because with the chain rule, you multiply by the chain, you multiply by the derivative of the inside part. Here you divide by that. Okay? All right, similarly, the antiderivative of cosine kx would be sine of kx divided by k plus c. All right, number 4. A lot of the rest of them are, remember I told you when we did the derivatives, I said it would be a good idea to memorize the derivatives of the 6 trig functions. This is why. Because see, if you remember that the derivative of the tangent of x is secant squared x, then it'll help you remember that the antiderivative of secant squared x takes you back to tangent x plus c. All right? So what do you think the antiderivative of cosecant squared x would be? What would be the antiderivative of cosecant squared x? What trig function has for its derivative negative cosecant squared?
Negative cotan x plus c.
Yep, so it'll be negative cotangent x plus c, because the derivative of cotangent is negative cosecant squared. Okay? All right, so what trig function has for its derivative secant x tangent x?
Isn't it secant x?
Secant x. So this will be secant x plus c. And then what would have for its derivative cosecant x cotangent x?
Cosecant?
Yep, but negative. Because the derivative of cosecant is negative cosecant cotangent. So kind of going back the other way, you have to put the negative somewhere. All right, so any questions on any of those? All right, so let's see how well you can apply the rules. All right, so what would be the antiderivative of x to the fourth using the anti-power rule? All right, Skylar, what do you think?
X to the fifth over 5 plus c.
Excellent, excellent. Okay? Everybody cool with that? So you add 1 to the power, divide by the new power, and then put the plus c. All right, this next one might take a minute. But Jordan, when you've got it, let us know.
X to the 2/3 power divided by 2/3 plus c.
Okay? X to the 2/3 divided by 2/3 plus c. Okay, that's correct, but we don't want our answer to include complex fractions. So dividing by 2/3 is the same as multiplying by what?
3/2.
3/2. So when you have this, then flip the fraction, and so that'll give you 3x to the 2/3 divided by 2 plus c. Okay? And then if you actually want to put it back in radical form, you could. But as far as I'm concerned, either of these last two answers would be great. Okay? All right, any questions on that? All right, let's try the next one. All right, so Rhett, when you've got that one.
Sine of 3x over 3 plus c.
Good. Good. Now, just so you know, like if you check that in the back of the book or something like that, you're doing some practice problems. They might, where you're dividing by 3 here, they might pull the 1/3 out front. Okay? So just know these two answers are equivalent. Okay? I mean, I'm not saying you have to do that, but you need to know that these two are the same. Okay? All right, Rachel, when you've got this one. Sine of 3x over 3 plus c. Good. Good. Now, just so you know, like if you check that in the back of the book or something like that, you're doing some practice problems. They might, where you're dividing by 3 here, they might pull the 1/3 out front. Okay? So just know these two answers are equivalent. Okay? I mean, I'm not saying you have to do that, but you need to know that these two are the same. Okay? All right, Rachel, when you've got this one.
Is it negative 3 cosine 1/3 x?
That's it. Plus c. Don't forget the plus c. Okay. Any questions on that one? You guys are doing great. Okay, so now some what we call linearity rules. So if your function has a constant, you can just sort of ignore the constant and take the antiderivative and then multiply it by the constant, plus c. So if you had, like, let's say you wanted to take the antiderivative of 5x. Well, then you say the antiderivative of x would be x squared over 2, and so then your answer would be 5x squared over 2. So you just sort of just put the constant with the answer. Now, if that constant is a negative, the same thing applies. You can just do the antiderivative and then just slap the negative in front. And then the last one says if you're doing the antiderivative of two functions that are adding or subtracting, then you can do the antiderivative term by term and then just put the plus c at the end. So I like these because there's no surprises. Everything pretty much works the way you think it ought to work. Okay? All right, so let's see if you can do practice 4. So that's kind of piecing together several of the answers from practice 3 or something similar. All right, so Joey, when you've got this one.
So it's x to the 5th over 5 plus 3x to the 2/3 divided by 3 minus sine 3x divided by 3 plus c.
That's it. Okay? Great job. Any questions on that? Okay. You guys are doing an excellent job with this, and that bodes well for the next thing. So, okay, part 6, antiderivatives and motion. If we know an object's acceleration, then by finding an antiderivative, we can recover the velocity. And from its antiderivative, we can recover the position. So what we've been doing is starting off with the position function, and you take the derivative to get the velocity, and then the derivative to do the acceleration. So now we're going to go back the other way. Okay? All right. So let's say that we have a balloon. And let's say it's going up at the rate of 10 feet per second. So that's its initial velocity. And then let's say that when it is 100 feet high, it drops a package. Okay? Like, I don't know if you ever heard of the candy bomber, but there was a guy in a plane that used to drop candy to the kids in Berlin after World War II. Kind of a famous guy. But anyway, so the acceleration due to gravity is negative 32 feet per second squared. Okay, So then to get the velocity function, you take the antiderivative of negative 32. So that's just a constant. So the antiderivative, v, is going to be negative 32t plus c. So now to find that c, we use our initial condition that the initial velocity is 10 feet per second. So that means we plug in 0 for time and 10 for v here and figure out what c is. So that we solve that for c and we get c equals 10. So then we take and plug in 10 for c and we get our velocity equation then, which is negative 32t plus 10. All right, now we do the same thing again to get the position. We do the antiderivative of v to get the position equation. So that would be negative 32t squared divided by 2. Well, so the negative 32 divided by 2 is negative 16. So we get negative 16t squared plus 10t plus another c. Now, you don't want to use the same variable, so that's why I did c1, or you can do c1 and c2 or whatever. You just don't want to pick a c again exactly because you already solved for c. So I'm just saying c1. So now to find that, I use this initial condition that the initial height is 100 feet. So I plug in 0 for t and 100 for s. And so then I solve for c1 and get 100. So then I plug that in for c1 and that's my final answer. So I have my velocity equation and my position equation. Okay? Okay, so let's see if you can do practice 5. All right, so Joey, what's the acceleration equation?
12 feet per second.
No. No, that's the 12, that's the velocity. That's the initial velocity is 12. So the only acceleration acting on this is gravity. Okay? So Joey, what's the acceleration due to gravity?
It's like 9.8.
In meters per second. What about in feet per second?
Negative 32.
Negative 32. So it's the same as the example I did. So negative 32 feet per second squared. That's the acceleration equation. Okay? All right, so now, Joran, what's the initial velocity?
12 feet per second.
12. So that's v sub 0. Okay? Here, I'm going to act. So the v of 0 or v sub 0, 12 feet per second. All right, so Hannah W., what is the velocity equation?
It'd be 12t plus c.
Okay? Now remember, the velocity equation is you do the antiderivative of the acceleration. So it's negative 32t plus c. Then you plug this in. Okay? You don't take the antiderivative of the 12. The 12 is what you use to figure out what c is. So when you plug in 0 for t and 12 for v, then you get c equals 12. And so then your velocity equation is negative 32t plus 12. So to get the general velocity equation is the antiderivative of the acceleration. All right, so Denon, what's the initial position? So it's kind of like when you start the experiment or whatever, you drop the package or whatever. What's the position?
80 feet.
80 feet. Okay? So you'd say S sub 0 is equal to 80 feet. So we're going to use that to find the specific position equation. Okay? All right, so Nathan, when you've got the position equation, let us know.
Negative 16t squared plus 12t plus 88.
Negative 16t squared plus 12t plus 80. All right? And then the last one says, how long does it take for the package to hit the ground, to reach the ground? Well, that actually isn't even a calculus problem. You just set the position equal to 0 and then solve it. So that's a quadratic. So you either factor quadratic formula or graph it. But they throw in, sometimes they'll just throw in an algebra problem in the middle of all this, where you're doing all this calculus, and then they'll throw in something where you got to use some algebra there. All right, so Joey, when you've got that, quadratic formula or graphing? Good, don't be sleeping, Jordan. Just kidding. Hey, didn't you say you're going to be gone on Monday and Tuesday as well, Jordan? Did you tell me that?
Yeah, so
Okay.
we're leaving Saturday for Colorado.
Okay, so make sure you come tomorrow and Thursday and do your quizzes and tests. And then Monday and Tuesday we'll be doing 5-1 and 5-2. So you're probably going to want to watch the videos on that when you get back. Okay? You'll be okay. Just get the notes. You'll be all right. Okay? It's not difficult, but it's hard to teach yourself that material. Okay?
So I got 2.5 seconds.
Okay? About 2.64.
Okay.
So did you graph it or did you use the quadratic formula?
I use the quadratic formula.
Okay, so you should actually, I mean, depending on where you rounded, 2.5 is a little bit off. I mean, so you might want to double check. I mean, here I did it with the quadratic formula as well. Now, at this point, I rounded, but what I would recommend you do, you know it's not going to be the negative because time can't be negative. So if you would just put in your calculator, well, you're going to need parentheses because this is more than one term. So parentheses, 3 plus square root of 329, close parentheses, divided by 8. And that should give you a little bit better answer. So maybe you rounded a little earlier than me.
Yeah, I accidentally put 324 into my calculator, so.
Yeah. And it's amazing that just that little bit, you know, would throw it off a little bit. Now, the good news is that I don't, you know, on a multiple choice test, I don't have the answers that close together, so that some little error like that shouldn't throw you off. But, okay. All right, any questions on that? All right, so what's the derivative? What's the antiderivative of horse derivative? This is actually a joke.
Horse.
You forgot the C, so it's actually seahorse. So, all right. Okay. So, all right. Now let's go on the last little bit here, where this is really the connection to chapter 5. And so it's really important. So don't shut out here before we drop out. So next we're going to be talking about the integral. Okay, integral is the next big idea. Well, the indefinite integral is written like this, and this is actually an elongated S. So the indefinite integral, what it is it's just the antiderivative. So it's another way of saying what we've just been doing this whole period here today, is find the antiderivative. So this elongated S is the integral sign, the function is the integrand, and the dx is the variable, the x is the variable of integration. So it's telling you you're doing the antiderivative with respect to that variable. Okay? Now we'll do some later that are more complicated that have more than one variable. But for right now, just know that the dx is important. It tells you what variable you're using. Okay? So here, if to evaluate this means, this integral sign means take the antiderivative of this function. Okay? So what would it be? What's the antiderivative of 3x squared? Well, technically, it would be 3x cubed. Well, actually, let's go back. It would be 3x cubed over 3 plus c minus. And then the derivative of 4x would be 4x squared over 2 plus another c. And then the antiderivative of 10 is 10x plus another c. But you don't have to write the plus c every time, because a constant plus a constant plus a constant is just a constant. Okay? So you only have to put the plus c at the very end, not when you're doing the antiderivative of each term. Okay? And then you want to clean this up a little bit. And so then that would give you x cubed minus 2x squared plus 10x plus c. Okay?
Mr. Strong, I like that smiley face in the 10.
Well, we made it through. We made it through. Thank you. So this idea of the antiderivative is what we're doing as we get into integral calculus. All it is it's the antiderivative. So don't get so in like movies and stuff, when they want to like make somebody look smart, they'll put these integral signs up there. All it means is just the antiderivative. And so it's not going to be complicated. You guys did great today. So I think we're going to be just fine in the next chapter. So anyway, okay, so we're all good for today for 4-7. Any questions? Okay, so quizzes tomorrow, test on Thursday, chapter 5 will start next Monday. All right? So we'll see you. Have a great day, the rest of it, and be safe out there.